So here we have the calculations to find the percentage yield for the reaction between copper sulfate pentahydrate and iron. Here is the full balanced equation for this reaction. Now in red we have the actual mass of the copper sulfate pentahydrate that was used, was 2.5 grams. We have the actual mass for iron that was used, which was 0.85 grams, and the mass of the copper that was created, which is 1.05 grams. Now here we have found the molecular mass for copper sulfate, hydrogen, and iron. So for copper sulfate, it is 159.62 grams per mole. For hydrogen, it's 90.1 grams per mole. And now here we have the two added together because it is copper sulfate pentahydrate. So we must combine the two molecular masses to get a final molecular mass of 249.72 grams per mole. And now here we have the molecular mass for iron, which is 55.85 grams per mole. And the molecular masses for copper, iron sulfate, and once again hydrogen. So I'm using the table method to find out the limiting reactant. I use the equation to find the mole ratio for copper sulfate pentahydrate and iron to find which one is the limiting reactant. Now as you can see here, I have the final amount for the number of moles, which was 0.010 for copper sulfate pentahydrate, and here for iron. Now, we can see that the copper sulfate pentahydrate is the limiting reactant, but due to rounding for significant figures, both values end up being the same. So it doesn't really matter which one you use. But then I found the actual mass for copper, which was 0.63 grams. To find my percentage yield, I put the actual yield over the theoretical yield. My actual yield was 1.05 grams, and my theoretical yield was 0.63 grams. So I got 1.68, which is 168%. Now, this percentage yield is higher than 100%, which shows that there have been some kind of errors made in the actual lab, because the percentage yield should not be over 100% and the actual yield should not be higher than the theoretical yield. Thank you.